All right, welcome to this section on Pascal's triangle. We shall be focusing on problems. We shall be taking problems at this section. And I have a simple example to illustrate for us. We have x plus 2y raised to power 5. Let me also bring this x minus 2y raised to power 5. I feel there is need for us to take note of two things. You can see that the signs are different. Now, when we have a positive sign, the sign spreads all over. It remains positive, nothing changes. But when we have a negative sign, it is vital for us to note that the sign will always alternate. So that means the first will be a minus, the second plus, the next minus, the next plus, and like that. That is when we have a negative sign. And then another thing we ought to take note of is that the signs, the coefficients of x will always reduce while that of y will increase. That is the principle. So during expansion, you will notice that as y decreases, x, okay, as x decreases, y takes its place. As x decreases, y increase. We shall see as we solve the problem. So in this section, we shall be taking this problem. We have x plus 2y raised to power 5. Let's solve using Pascal's triangle. Now, let's consider the rule. Let's consider the power. Because we have the fifth power, it simply means that we shall be making use of 1, 5, 10, 10, 5, 1 in solving the problem. That is the coefficient. These are the coefficients. We shall be using these coefficients to solve the problem. Now, this is how it is done. The first one will go for x, so we simply have it as 1 times x, 1 times x raised to power 5. So we have it as 1, although 1 is 1, it really has no effect on multiplication. So x raised to power 5, x raised to power 5 times 2y raised to power 0. The next one, because we have a plus, we are adding. The next one, the next coefficient we have to use is 5. So we have 5 times x. Now, like I said earlier, as x reduces, y will increase. Now, 5 plus 0 gives us 5. 5 plus 0 gives us 5, and that is the power of which we have here. So x will always decrease. So instead of having 5 here, we have x to be 4. You can see it decrease. Now, as it decreases, y will also move from 0 to 1. Now, watch, this is what I mean. Times 2y raised to power 1. Initially it was 0, but now it is 1. Plus, our next coefficient is a 10. So 10 times x raised to power 3. You can see it is decreasing. It is decreasing. While y will be increasing. Multiplied by 2y raised to power from 1 to 2. It is increasing. The next coefficient, we have a 10. So we have 10x raised to power 2. It was 3, now it is 2. Multiplied by 2y. It was 2 here, so it's increasing to 3. The bottom line is that it must equate to give you the power. You can see 5, 0 is a 5, 4, 1 is a 5, 3, 2, 2, 3, it is 5. The next coefficient we have is a 5. So 5x raised to power 1, it was 2 here, now it is 1, multiplied by 2y raised to power 4. And then finally we could do this. 1 is 1, that's the last coefficient. So 1x raised to power 0. So 1 times x, 1 times x raised to power 0 times 2y raised to power 5. From 1 to 0, from 4 it got to 5. So this is the expansion. Now what does it mean? It simply means that, recall we said any number raised to power 0 is equal to 1, so everything here cancels to the 1. And then we have 1 times this, which gives us x raised to power 5, plus this simply means 5x raised to power 4 times 2y plus 10x raised to power 3 times 2 square is 4, y square gives us y square plus 10x square times 2 raised to power 3, 2 times 2 times 2 gives us 8, y raised to power 3 is a y cubed plus this is 5x times, each time I use a dot it represents multiplication. 2 raised to power 4 gives us a 16, and y raised to power 4 gives us y raised to power 4 plus any number raised to power 0 is 1, so automatically this is 1. 1 has no effect on this, so we have 2y raised to power 5. So that equates to x raised to power 5 plus, watch me, 5 times 2 is 10, 10x4y plus 10 times 4 is a 40, x cubed y square plus 10 times 8 is an 80, x square y cubed plus 5 times 16 is an 80, x y 4 plus 2 to the 5th power is a 32, y raised to power 5. Now this gives us the result, the final result of this correlation of this expression here. That is to say that we have x raised to power 5. You see the coefficient 1, 10, 40, 80, 80, 32. Now watch this. For every decrease in the power of x, there is an increase in the power of y. Now watch this. From 5, 4, 3, 2, 1, 0. Y increases. You can see 2, 3, 4, 5. It is a way to show that you are correct, you are in line with the expansion. So this is how to apply Pascal's triangle in solving complex problems, in solving problems that has to do with numerous powers, higher powers. Do well to try some more problems and feel free to hit me up anytime. As I bring this to a conclusion, don't forget to hit the like button, turn on the notification bell, and see you at the top. Thank you.